Hi, we're Group 9, and this is our Challenge 1 Nest video demo. As you can see from our demo here, we have our Nest thermostat that shows both Fahrenheit as well as Celsius, and it is recording from our 4 sensors. We have our first 2 sensors over here. Our sensors consist of the thermistor, the Zigbee module, as well as the Arduino code that will both has been calibrated to both show the correct temperature and send it over to our main computer, as well as our other 2 modules at the other side of the room. See, you can take them.
Here are the other 2 Arduinos with the thermistor and the XPs. They're currently transmitting to the main coordinator over there. So
and it all reports back to the main base and calculates the average as well.
The extra functionality that we added to our setup here was that we made this robust and scalable by having it so that when new Arduinos are added, all you have to do is add new code to it and just upload. So you upload the code and then it'll automatically start running. So if you see here, when you take off this Arduino, it should update the web page. It does take a little while so that it doesn't randomly just disconnect one of them when it doesn't get a signal. But then if you add it back, it'll re-add it. So it takes a little bit of time, but so yeah, and the keys are so that basically there's a max number of devices that can be added, and then that's configurable. You can just change that to whatever value you want. So as you can see, sensor 3 was added because it reuses keys.
So this is our Arduino code, and here we generate a random number and send it to the coordinator so that the coordinator can recognize the Arduino and make a handshake. And the Arduino code also calculates the temperature, and we use the Steinhardt function to do so, to convert the resistance to the temperature value.
For the coordinator code, we have it set up so that it pulls all the available devices on the local network for new temperature information. By doing that, we also have our clean keys function, which is what allows us to, every nth iteration, monitor what devices got disconnected and are no longer transmitting information. This allows us to update the temperature dictionary as well as refresh available keys and keys currently in use for other devices. Once we have a temperature that is received through JSON from our Arduinos, this gets added to our temperature dictionary, which then gets sent to the client for further display.
HTML side, we have a dictionary which stores all the averages from the different devices, and we average the temperature together to display it. We also have a button that toggles between Fahrenheit and Celsius and does the conversion. And all in all, it'll give you this result.